Let's take a look at what they've given us here. We have a definition of an ellipse. We have all of these coordinates. We have foci, foca. How do you say that word? Foci. That's what we're going to go with. That's the way I say it. And we have all of this stuff here that's just more characteristics and features of an ellipse. Y'all, it's a lot. I will explain it as we go. Let's look right here. That is the equation for an ellipse. Notice that this part and this part here kind of matches what we learned last unit. Kind of similar to a circle. This helps us find our center. We have an a squared and a b squared on the bottom of our fraction, and these are all equal to 1. They should be all equal to 1 if it's an ellipse. Now, with an ellipse, it can be either horizontal or vertical. And of course, you can tell which is which by looking at the picture. If it's horizontal, the major axis is going to be horizontal throughout the ellipse. The minor axis is going to be vertical. And if it is a vertical ellipse, then your major axis is going to be vertical along the ellipse and the minor axis will be horizontal. Now, but what if they don't give you a picture? How could you tell? Look here at this equation here. Here's an equation for a horizontal ellipse. Here's an equation for a vertical ellipse. Do you notice the change in A and B? Wherever A squared is, that happens to tell you which axis is going to be the major axis. So here we have a horizontal ellipse, meaning the x-axis is the major axis, and our A value is under X. Here we have a vertical ellipse, meaning our major axis is vertical, and look, now the A is under Y. That's one way you could tell what you're dealing with without having a graph. We're now going to label the vertical ellipse. I'm not going to label every single coordinate and point on here because it can be a lot. I just want you to get the main portions. So from here, the end of the ellipse to the center, that is our A value. I should probably use different colors here. Let's go with green. So from center to the end of the ellipse on the major axis, that is A. From the center to the end of the ellipse on the minor axis, that is B. And then from the center to that point that doesn't quite reach the end of the ellipse on the major axis, that is point C. That is the foci. Now, before we go on to side 2, obviously these are the 2 main equations that we're going to be dealing with today with ellipse. Also take note of this one. It looks familiar, doesn't it? It looks like the Pythagorean theorem, but notice that instead of a squared plus b squared, it's a squared minus c squared. And that is how we calculate the center to one focus. Anyway, we'll be using that a lot today too. Example 1, write an equation for the ellipse. We can tell by this graph that we are at the origin here. So when there's no vertical or horizontal shift, we're going to be x squared over something plus y squared over something, and we're going to be equal to 1 here. Now take note of which axis is the dominant axis. In this case, it's the x-axis because it's the one that is longer. So our A value, I'm going to write that here. Our A value is going to be related to our x. Our B value is going to be related to y. And then from your center, just count how many hash marks would we have to go to get to one end of the ellipse. 1, 2, 3, 4, 5, 6. So A equals 6. Now on the minor axis from the center, let's see how many we have to go up. 1, 2, 3, 4. So our B value is 4. This is going to be our A squared value. Well, we know what A is, we just have to square it. This is going to be our B squared value. We know what B is, we just now need to square that. And we have now written the equation for that ellipse. Fill in the blanks and graph for example 2. is major axis horizontal or I feel there should be a V there, but whatever. Is the major axis horizontal or vertical? We'll look under your X and your Y, which number is bigger? 25. That's under the X value. So our major axis is going to be horizontal. I'm also going to make a note that our A value is going to be the square root of 25, which is 5. Our B value is going to be the square root of 16, which is 4. That's going to help us with graphing. X squared and Y squared, we don't have any vertical shifts, so our center is 0, 0. Remember, our dominant or our major axis is going to be horizontal. So we're going to look at our A value, and from the center, we're going to go right 5. 1, 2, 3, 4, 5. And then from the center, left 5. 1, 2, 3, 4, 5. Our minor axis is going to be a length of 4 from the origin. So from the origin, we're going to go up 4. 1, 2, 3, 4. From the origin down 4. 1, 2, 3, 4. Draw the best graph you can. I'm going to now, I'm going to use a darker pen here. I'm going to highlight my major axis to make it stand out a little bit more in my minor axis. Okay, vertices. Now notice that we have vertices and we have co-vertices. Your vertices are going to be the ends on your major axis, and we would just need those coordinates. This coordinate here, I believe, is -5, 0, -1, 2, 3. Yep. So -5, 0 is one of our vertices, and the other one is this one here, 5, 0. Your co-vertices are going to be the end of your ellipse on the minor axis. So from the origin, we have to go up 1, 2, 3, 4. So that's 0, 4. And then from the origin, we'd have to go down 4. 0, -4. I'm going to get out a separate sheet of paper because now we're going to have to do a little bit of math in order to find our foci. Let me do this. Okay. So that formula, remember, it's A squared minus B squared equals C squared. C represents our focus. Our A value is 5, and 5 squared, we need to be squared, is 25. Really, all you need to do is just keep the numbers underneath your fractions. And just remember which one's A, which one's B. So 25 minus B squared, our B term is 4 squared to get 16, and set that equal to C squared. 25 minus 16 is 9. Square root. So our focus is 3. More accurately, it is 3 spaces away from your origin, or from your center. I should say center more accurately. It is 3 spaces away from your center on the major axis. So here's our center. So we need to go 3 away from it in the positive direction. 3 away from it in the negative direction. And we now have our focus. Let's now put those as an ordered pair. So that one there would be -3, 0. And this one would be +3, 0. Length of the minor axis. Well, this is our minor axis. You could count from here all the way to the bottom. 1, 2, 3, 4, 5, 6, 7, 8. Another way is if you know which one of these A or B is the minor axis, you could just times it by 2. So B represents minor axis, times it by 2 to get 8. Length of major axis. A represents half the length on our major axis, so multiply it by 2. 10. Domain are going to consist of all our X values from left to right. So that would be -5 to +5. And range consists of all of our values that this graph is going to cover from bottom to top, which would be -4 to +4. Let's go on to example 3. Is the major axis horizontal or vertical? Well, let's look underneath these fractions. This doesn't have a fraction. It's not in fraction format, but I can do that by putting it over 1. Now, which one of those fractions has the bigger denominator? That would be the y fraction. So this is going to be vertical. Here's what that means, y'all. That means this is now our a value. This is now our b value. And in order to find your a and b value, take the square root of these denominators. So the square root of 9 is 3. The square root of 1 is 1. That's going to help us when we start graphing. Notice that x squared and y squared on top of our fractions are just x squared and y squared. So our center is still going to be the origin. Now that we know the length of our segments from the origin, we can begin graphing. Now remember, our a value, that helps us graph the major axis, and our major axis is now vertical. So from the origin, we need to go up 3 and we need to go down 3. B helps us graph a segment on the minor axis. And since our minor axis is horizontal, from the origin, we want to go right 1 and left 1, and then graph your ellipse. And then I want to try and point out that this is our major axis. This is our minor axis. Vertices, remember, vertices are going to be the end coordinates of your major axis. So from the origin, we have to go up 1, 2, 3, 0, 3. From the origin, we have to go down 3, 1, 2, 3, 0, -3. To find your co-vertices, those are the coordinates at the ends of your minor axis. So we have one at -1. We have one at +1. Now we have to figure out what the focus is. Let me get my separate sheet of paper once again. Write down that formula for you. A squared minus b squared equals c squared. Our a value is 3, square it to get 9, minus our b value is 1, square it to still get 1. And we're trying to solve for c. Square root. I'm going to leave that for right now as the square root of 8. Where and how do we plot the square root of 8? Well, we're going to have to do a little bit of thinking. Let me section off my work here. We have to figure out how would we graph the square root of 8. In order to figure that out, you got to think about what is the nearest perfect square after the square root of 8, and what is the nearest perfect square before the square root of 8. So here's what I mean. The nearest perfect square after the square root of 8 is the square root of 9, and the nearest perfect square before the square root of 8 is the square root of 4. Now, I know what the square root of 4 is. That's 2. I know what the square root of 9 is. That's 3. Therefore, the square root of 8 must be somewhere in the middle, somewhere in between. Don't worry about getting it exact. Just put it in between 2 and 3 when you go to graph. So if we're going to graph our focus, remember, it's going to be about 2.5 away from the center on the major axis. This is our major axis. Here's our center. So up 1, 2.5, down 2.5. So we have now graphed foci. But whenever we go to actually list that as an ordered pair, we're going to have to reduce the square root of 8. We want to make sure these are fully reduced. Here's how I like to do it. I just like to divide by the lowest number possible. We now have nothing but prime numbers, so we're done. We're looking for pairs and what's left over. Anything that's left over goes back in the root, and whatever you have circled, only one number from that group gets moved to the outside. So this reduces to 2 root 2. So as an ordered pair, that would be this dot here, that dot right there, that focus is 0, 2 root 2. This dot in orange, that focus is 0, negative 2 root 2. Okay, the length of the major axis, we're going to take A and double it. Length of the minor axis, we're going to take B and double it. Domain, all of the x values this graph covers from left to right. So from -1 to +1. And our range are all of the y values that this graph covers from bottom to top. So from -3 to +3. For example 4, write the equation of the following with the given characteristics. For example 4, they have given us our vertices and our co-vertices. Notice that for your vertice, these are going to reside on the x-axis. For your co-vertice, these are going to reside on the y-axis. So this is a horizontal ellipse. Meaning our a squared value is going to be below the x portion. So we know we're going to have x squared over something plus y squared over something is equal to 1. Since our a value in both of these is 5, they would be 5 units of space away from our center. Here our b value is 3 units of space from the center. So now you just want to square both of these. 5, 9. This number is going to go below your x. This number is going to go below your y. And that one is now done. For example 5, they have given us now co-vertices. Co-vertices, remember, that is going to be the minor axis. And they have given us the foci. Our center of this ellipse, once again, is the origin. It has been the origin for both of these. So here's what they've given us. If they've given us a co-vertice, they have given us a b value. If they've given us our focus, we have a c value. What we don't know is we don't know the vertices of our major axis. So we don't know what the a value is. That's what we're going to need to solve for here to help us. Since our co-vertice has 12 units of measure from the center, we know that b is 12. B represents minor axis. Since our foci is 5 units of measure from our center, that means our c value is going to be 5. So now we can use our equation for finding focus and substitute where necessary. We don't know what a is, so we're going to keep that a squared minus our b value. We need to square that. And then we need to square our c value. Now we know what our A value is. It's 13. In order to complete this problem, we only need to take note of our A value and our B value. So A is 13. B is 12. So we know we're going to have x squared over something plus y squared over something is equal to 1. And then you have to remember which one of these denominators gets the A value. It's going to be the one that has the major axis. And our major axis in this case is going to be y. So we would take our A value, which is 13, and we want to place it here, but square it. 13 squared is 169. We're going to take our B value and square it and put that here to get 144. And that's your answer. Example 6, is the major axis horizontal or vertical? If we're looking at our x portion and our y portion, looks like the x portions has the biggest number. 36 is bigger than 4. So this is going to be horizontal. So this is going to be our A value. This is going to be our B value. In order to find our A value, take the square root of 36. In order to find the B value, take the square root of 4. And remember, that's going to help us with graphing. Okay, now looking on top of our fractions, we are going to have a horizontal and a vertical shift from the origin. And remember, it's opposite of what you think it would be. So I'm just going to give you the answer for the center. -4, 1. See, 4, but just flip the sign. 1, -1, but flip the sign. That's our center. So let's plot that. -1, -2, -3, -4, up 1. Our A value is 6, and that's going to be horizontal. That's going to be our major axis. So from the center, we're going to go right 6 and left 6. Our minor axis, that's going to be B. That's going to help us with the graphing. So B equals 2. So from the center, up 2, down 2. Where did my Sharpie go? Okay, vertices. Vertices, remember, those are going to be the endpoints of your major axis. So it looks like in order to get to that dot there, that coordinate, we'd have to go left 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and up 1. And then in order to get to that dot there, looks like we'd have to go right 2 and up 1. Co-vertices, those are going to be the endpoint of your minor axis. So in order to get to, let's do this one first. From the origin, we have to go left 1, 2, 3, 4, down 1. And in order to get to that vertex there, we'd have to go left 1, 2, 3, 4, and up 1, 2, 3. Now, focus. Not only do we need to find focus, I need you to focus because these are going to be a little different than the ones we've done earlier. That formula, once again, to find focus, A squared minus B squared equals C squared. Well, our A value is 6, so square it. Our B value is 2, square it. And now let's start solving. Okay, so C is equal to the square root of 32. Square root of 32. What perfect squares surround 32? 36, and 25. I know that the square root of 25 is 5. And I know that the square root of 36 is 6. So this must be somewhere in the middle. It's going to reside on our dominant axis. And it's going to be about 5.5 away from our center. So 1, 2, 3, 4, 5.5. And then left 1, 2, 3, 4, 5.5. And remember, we have to reduce the square root of 32. If you have a method that works for you, you do it your way. If you've kind of struggled with these in the past, this usually helps. So just keep reducing by the lowest number you possibly can over and over. Ooh, we got a lot going on there. What we're doing is we're looking for pairs. Anytime you're taking the square root of a number, you're looking for pairs. So there's a pair of 2s. There's a pair of 2s. That's left over. Anything that is left over goes inside the root. Anything that you have circled, one number from that circled group gets moved to the outside. So one number from that group gets moved to the outside, one number from that group gets moved to the outside, and then multiply where necessary. So this reduces to 4 root 2. Now that is not our answer. That's part of our answer, but that's not our answer. So these where these get a little complicated. So our focus is the distance from here to here. Since the focus resides on the x-axis, what we have to do is we're going to start with, well, what is the x value of our center? And the x value of our center is -4. So we're going to have to go, I've lost my space. Here we go. We're going to have to go, we're going to have to start at -4, and then we're going to have to go left -4 root 2 spaces. So the way that you write that is -4 minus 4 root 2, and then comma 1. Because in order to get to that red dot or that orange dot right there, from the origin, we'd have to go left -4, and then -4 root 2 spaces, and then up 1. So these are going to have the exact same y value. This focus and that focus. So I'm going to go ahead and put 1 here. Okay, now in order to get from the center to here, we need to start with our x value, because remember it's on the x-axis, and then this time we're going to add 4 root 2 units of measure. All right, length of major axis, the a value, multiply that by 2. Length of the minor axis, b value, multiply it by 2. Domain, all x values this graph covers from left to right. That would be -10 to 2. And then your range, all of the y values this graph covers from bottom to top. That would be -1 to 3. -1 to 3. And that one's done. Example 7. Is the major axis horizontal or vertical? We have the bigger number under y, so we're going to be vertical here. So this is going to be our a value. We're going to have a b value here. Square root of 36 is 6. The square root of 16 is 4. Let's start graphing. Our center is going to be 2, 3. Our major axis is going to be vertical, so we're going to go up 6, down 6. Our minor axis is horizontal, so from the center we're going to go right 4 and left 4. Vertices, those are going to be the the endpoints on the major axis. So it looks like we're going to have one at 1, 2, from the origin 1, 2, and then up 1, 2, 3, 4, 5, 6, 7, 8, 9. So that should be 2, 9. And then this one here would be 2, -3. Co-vertices, those are going to be the endpoints of your minor axis. From the origin, we'd have to go left 2 and up 3 to get to that one. And in order to get to that co-vertice there, we'd have to go right 6 and up 3. How about we do the easy stuff first? Okay, length of major axis. Let's take your A value and double it. Length of minor axis. Take the B value and double that. Domain are all the values that this graph covers, all the X values that this graph covers from left to right. So that's going to be from -2 to 6. And then the range are all the Y values that your graph covers from bottom to top. So -3, 9. Now let's go figure out that focus or foci, because there's going to be 2 of them. A value 6. Our B value is 4. That formula once again. So let's go. Take your A value and square it. Subtract your B value once you square it, and set it equal to C squared. 36 minus 16 is 20. Oops, just C. Okay. Square root of 20. That is in between the square root of 25 and the perfect square of 16. Well, that is 4. That is 5. So this must be somewhere in between 4 and 5 on our major axis. So from the center, go up 1, 2, 3, 4. 1, 2, 3, 4.5. And then from the center down 4.5. 2.5. Now let's reduce the square root of 20. That would be 2 root 5. So what we're going to have to do is we are going to have to, from the center, we want to use the Y value of our center and either add or subtract 2 root 5. So 3 plus 2 root 5. 3 minus 2 root 5. Okay, now this has to be an ordered pair. We are on these foci are on the y-axis. So for each of these ordered pairs, we need to have an x value, but it's going to be the exact same x value. It's going to be whatever the x value is of your center. So 2 and 2. And that one's done. Okay, write an equation for the ellipse. Our center is 1, -2, or x value is 1. So in our equation is going to be x minus 1 squared over, we'll come back to that in a little bit, plus y, our y value is -2, so that's going to switch to +2 squared over something. We have to figure out, this one's going to be vertical. We can tell that we have more distance vertically than we do horizontally. So this is going to be our A, this is going to be our B, and let's just figure out, well, how much distance is it from center to the vertice there? Looks like we'd have to go 1, 2, 3. So our A value is 3. So just square that and put it underneath the y fraction. In order to get from the center to the co-vertice, we have to go right 1, 2. So our B value is 2. Square that, put it underneath the x fraction, set it all equal to 1 because it's an ellipse, and we're done. Example 9, complete the square to write the equation of the ellipse in standard form. Let's start by bunching. I'm gonna go a little bit faster through these because we learned the concept of this last class. Bunch your x values. Then bunch your y values. And set it equal to anything that doesn't have an x or a y, move it to the other side of the equal sign. And since it's positive here, we're going to subtract it over. Okay, now here's what I'm going to do. I'm going to do 9x squared plus 36x. I'm going to go ahead and create that space there. Plus 4y squared minus 24y. Create space there. Set it equal to -36 plus blank plus blank. And I'll explain again why we're doing that in just one moment. Now, here's what we have to do. We have to factor out the number in front of x here in this case. So we're going to factor out a 9, and that would leave me with x squared plus 4x plus blank. And now we're going to start the process of completing the square by taking our b value here, divide it by 2. That would give us +2. And then we're going to square it, and we put that result here and here. But wait, you see how we factored out the 9? If we were to distribute that 9, we'd have to distribute it to the 4 there. So we're really doing 9 times 4 here, meaning we have to do 9 times 4 there also. Plus, let's complete the square here, factor out of 4. Your b term is 6. So divide that by 2. You would get -3. We're now going to square that. So we're going to do a 9 here and here, but we have to include the fact that we're going to eventually, we would multiply that 9 by 4. So we have to do the same thing here. Okay. Now, in order to put our final answer, let me just give you a template. Okay, here we're going to have x, and then whatever the number is that we have in parentheses there. It's a +2, so put +2. Here, we have a -3, so we're going to do y -3 here. Equals, well, -36. 9 times 4 is 36. Those cancel. 4 times 9 is 36. So all we have left is 36. Out of habit, I prematurely drew these fraction symbols. I probably shouldn't have done that. In fact, I shouldn't have, sorry. Like I said, habit. Okay, now watch, this is what our equation should look like. Remember, in order for it to be an ellipse, it has to be set equal to 1. How do we do that? Whatever we have over here on the right side of the equal sign, divide by that number. And we have to divide everything by that number. And as I'm working this out, I see that I actually forgot some things. Remember how we factored out a 9 and a 4 here? We need to include that. Okay, now we're going to start simplifying. 9 and 36, we could reduce that to that. Here, these would reduce accordingly as and we set that equal to anything divided by itself is 1. That's your answer. Okay, last one. Let's bunch our X's together. Bunch your Y's together. Anything that doesn't have an X or a Y, swing it over to the right side of the equal sign. Okay, I'm going to go a little faster here. Feel free to pause if you need to. I'm going to go ahead and factor out my 25 here. And leave me some space for completing the square. Here, I'm going to go ahead and factor out 16. I don't know what 320, I think it's 20. That is 20. Yes. Plus. Okay, let's go. Let's take that number, divide it by 2, square it. That's what we're going to write here and here, but don't forget, we have to also include the fact that we're multiplying it by 25. Okay, let's take this number here, divide it by 2, square it. Put that number here and here. But don't forget, we have to include the fact that we're multiplying it by 16 also. Okay, so let's start. X, keep the number, plus 1 squared, plus Y, keep the number, squared, equals, let's add all that together. I don't know what that is. Looks like here we have 1600 plus 25 times 1, which is 25. And then subtract 1, 2, 2 to get 400. What did I forget, y'all? I forgot something, didn't I? See? These require so many steps. It's just easy to forget something. I forgot to bring down those that we factored out. So let me put a 25 here. 16 there. And then in order to solve this problem, we need this to be equal to 1. So we're going to divide everything by 400. And if we reduced, we'd get that's your final answer. Now, for this part here, what identifying characteristics of the equation above let you know that you have an equation for an ellipse? Well, you may have noticed that your x squared and your y squared are going to have different numbers. They're going to be positive, and your ellipse needs to be equal to 1. So write that down in whatever way makes sense to you. Your assignment's on Delta Math.